In this recording, we will discuss different forecasting methods, and more specifically, we will start with different forecasting methods including moving average, weighted moving average, exponential smoothing, and then we will move to different methods that are used to measure accuracy of forecasting methods including mean absolute deviation, mean squared error, mean absolute percentage error, and then we will discuss seasonality, how to calculate seasonal index, and then finally we'll move to regression and two further topics that will fall in regression are seasonality with trend and seasonality without trend, and we will be doing this on Microsoft Excel. So we'll start with moving average. This is our time series, and let's say if I have to calculate 3-period moving average, and for 3-period moving average I will write my answer in front of the fourth one because it's a forecast for the future. That's average of these three. Okay, so that's a forecast for using a 3-period moving average. Now let's say if I do the same thing using a 5-period moving average, then it will be, now in this case I will write my answer in front of the sixth value because I'm using 5-period moving average. So this is equal to, so the average of 5 periods this is 5-period moving average. And we can also do it in another way, that is just by clicking on data, click on data, and then after that data analysis, and in data analysis you see moving average is there at the bottom, and then click OK, and then here is input range, that's input range, and then interval. Let's say if I choose 3-period moving average and I want my output range to be here. Let me hide this one so that we can make a comparison. So you see, moving average using data and data analysis tool also gives identical results. Okay. Then in the next one we calculate weighted moving average. The idea of weighted moving average is that we recognize that in this one, in our forecast, the values that are more recent, they are more important, and the values that are old, they are relatively less important. So we want to assign more weightage to recent values and less weightage to old values. And let's say for this purpose I uh, use 3 period moving average, and I use weighting scheme that's 60%, 30%, and 10%. So that will be 49, and that will be multiplied by 0.6, and that's the highest weight, and then plus 44, and that will be multiplied by zero point 0.3 plus 42 multiplied by zero point 0.1, and that gives 46.8. Again, the idea behind weighted moving average is that we do recognize that, for example, let's say in these three values, 49 is most important. It is current. It has more value, more weightage compared to 42 and 44. So therefore, we assign it more weightage. So this was assigned 60% weightage. 44 was assigned 30% weightage, and plus 42 that was assigned only 10% weightage. Next method is exponential smoothing. For exponential smoothing, again, click on data and then data analysis, and then we have exponential smoothing here. In exponential smoothing, input range remains the same, that's our time series, and dampening factor let's make it 20% or 0.2, and we want our results to appear here, and then click OK. And this is exponential smoothing. I will drag it one cell above. So this shows that for the first one we don't have, it's not applicable, which means we don't have any forecast, because obviously at this point we did not had any data. However, once we have data, then this value, the first value, it's moved here. That becomes our first forecast, and then afterward forecast is calculated. So that's exponential smoothing. And again, in exponential smoothing, there are two inputs. One is about input and the other is dampening factor. Dampening factor over here I used, it's also called as alpha. I used 20%, and you can use different factors. You can use like 0 0.1, 0 0.2, 0 0.3, 0 0.4, like that, based on trial and error. In general, when you see there is less variation and you want your forecast to be more close to that, then you will use a smaller value of alpha, 0 0.1, 0 0.15, 0 0.2. However, if you see there's more variation and you want your forecast to be more responsive to those changes, and you want those changes to be reflected in your forecast, then you may wish to use higher value of alpha. And again, this is a trial and error method, and results we can later on check using accuracy of forecasting methods. Our next topic is to determine accuracy of forecasting method. Please note that this one is not about forecasting, but rather a method to assess accuracy of forecasting, which means how accurate is our forecasting. We will be comparing in different methods. So for instance, let's say if we want to see, if we want to make a comparison of moving average 3 and moving average 5, and we want to see which forecasting method is much better. For this one we use the first technique is called as MAD, that's mean absolute deviation or mean absolute error, and we are using it with the forecast of moving average 3. So for this purpose what we do is that we take difference. We'll be using these values. Let me hide them temporarily. So first we will take a difference of a time series and forecast, and there will be some negative values as well. Negative values when um, forecast is larger than time series, but we are not interested in those negative values because we are only interested in knowing how far they are. So for this purpose we take absolute difference, that's time series minus forecast, and then you can drag it, dragging only up to here because no value is available here, and here uh, we take average is equal to average, and it shows that mean absolute deviation or mean absolute error is 3.65. Okay, now we do the same thing with uh, moving average using 5. Now for this one, again we take absolute difference is equal to absolute and difference of time series minus forecast, and then we take average and that turns out to be 3.57, and of course this 3.57 is less than 3.65, which indicates that using 5 period moving average gives less error, and therefore 5 period moving average is better than 3 period moving average. Okay, next we will discuss MSE. MSE, that's also called as mean squared error. In mean squared error we will be using results of exponential smoothing. Mean squared error, we take difference, and again we know there will be some negative values. In order to these negative values, they can distort our average because we'll be taking average in the next step at the bottom of this column, and these negative values, they can distort our average. So to avoid that, we will convert those negative values into positive values by using another way, that's taking square. So first of all we take difference of time series and forecast, and then their square, and their average will be 19.98. Now we can also use the same procedure with um, moving average a 3 period, or moving average 5 period, or weighted moving average, and then we will compare this score with the results of other method, and whichever is less we will choose that technique. And finally we will use another last technique that's called as mean absolute percentage error, and we will be using this with exponential smoothing forecast. So for this one, what we do is that again we take absolute value because we don't want negative values, forecast minus actual time series minus forecast, and then so that's error, and then we take percentage error, so that's percentage error, and And when we take its average, average will turn out to be about 8%. And we will repeat the same process with 3-period moving average, 5-period moving average, and weighted moving average, and then we will see whichever gives lowest error. The one that gives low error, that will be technique of our choice. In next topic, we are going to determine seasonality in our data. There is a possibility that data might show some seasonality, which means there's a pattern. So for example, let's say we have data here. We see it's maybe like number of days 1 2 3 4 5 6 7, and then next week starts, and like that. We will be calculating seasonal index using one method that's called simple average method. And the first step is that we will sort our data like this one, that data for similar seasons, it appears in one row. So this is all data about Saturday, Saturday 80. Let's say we say one is Saturday and it's 80, and then after that this is 82, and similarly uh, we keep going ahead, and all this data is organized like this one. We are assuming this is Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, like that. And to calculate seasonal index, what we do is that we take average of each row, and then I drag to calculate average of all rows, and then this is overall average. In the next step, we divide average of each season by the overall average, is equal to this one divided by this one absolute value, and then I can drag it, so we get this one. And that's called as simple average method. So over here we see that for Saturday it's 0.89, or it can also be, what does this mean? It means that 0.89, it means that on Saturday sales is 11% less than the average sale in the first season, that's from in the first week. 0.89 plus 0.11 is equal to 100. Similarly, this is about 83% of sales on Sunday is 83% of the sales of the average sale in that week. In other words, sales on Sunday is 17% less than the average sale in this season. Similarly, sales on Monday is 88% of the average sale in that season. On Tuesday, uh, sales is 2% more than the average sale in the season, and over here sales is relatively very high, and that's on Wednesday. And we can also see here it's 135, which means it's 144% of the average sale of the season, or we can say it's 44% higher than the average sale in this week. And similarly this one, which means sales is 48% higher, or this is 148% of the average sale in this 1 week. And similarly this one, that's 46%, which means that sales is 54% less than the average sale, like this, of the week. This is called a seasonal index. So this seasonal index, it gives us an idea that what will be the sales and how different seasons they have their impact, or how they relate with the overall sales. And usually the sum of these one is should be equal to 7 because there are 7 period. If it's 7 then it's okay. If it's not, then we do some normalization in the next column. Okay, it's 7, so which means we can go ahead with this one. Then the next method that is used for computing seasonal index is called as centered moving average method, or CMA. Now in this method, let's say for instance we have, let's say this is our data, and as you can see here it's like Friday, Saturday and Sunday, and then again Friday, Saturday, Sunday starts again Friday, Saturday, Sunday, so which means that it's like 3 period. So we are going to use here MA3. If it's like something Thursday, Friday, Saturday, Sunday, it would mean there are 4 periods, and in that case we will need to use 4 period moving average. So what we do is that we use 3 period moving average of these 3. So that's 3 period moving average. Now the next thing is that next step is that we need to see that okay, this 188.33, that's the average that we got from these 3 values, and if we have to assign this 188.33 to any of these values, whether it's 149, 250 and 166, we can say that this most probably it relates with the central one. So what we do is that we rearrange this data so that it corresponds with the central one. This one. So over here we can say that this 188.33, it can be thought of as corresponding with the middle value. So that's called as a centering moving average. That's the second step. The first step is calculating moving average, and second step is centering moving average. In the next step, we take a ratio or divide time series by this centered moving average. So that's what we get. And in the last step, what we do is that we take average of similar seasons. So for example, this one average, this is this is Saturday, so I click Saturday, and then this is next Saturday, I choose this one, and then this is next Saturday, and then this is next Saturday, and this is last Saturday, and then bracket close, and I will put enter. So again, the overall idea is that we want to take average of similar seasons. I mean here like number of days, like these days. So Saturday is one season, Friday is another season, and Sunday can be considered as another season. So what we do is that we take average of Saturdays only here, and that's 1.343. And in the same way, you can do this thing for Sunday, which mean you will be taking average of only Sundays, which mean this one, this one, and this one. And similarly, the last one will be Friday, which mean we will be taking averages of only Friday, which mean this one, this one, this Friday, and this Friday, and the last Friday. So we'll be taking average of only these. Although we can manually do that, or I can just drag it and the same pattern will be transferred there. So that's called as so over here we see that seasonal index for Saturday is 1.343, and For Sunday, it's almost 0.868, and for Friday, 0.789. Now, one last thing that we usually do is that's normalization. And that normalization is that what we do is that we understand that the sum of these values, they should be equal to 3. If one value is more than above 1, the other is less than that, so overall it should be equal to 3. So let's see if they are equal to 3, then it's okay, otherwise we will do normalization. So it's almost like equal to 3. So what we can do is that we can uh, divide this one by this one absolute value and multiply it by 3, and that process is called as normalization. Over here it does not make much difference because this value is very close to 2.99. Actually it's almost like that, so you see here not much difference. And if you take sum of these one, then it should be equal to 3. So this is equal to 3. Okay, now we can, so this is we get this one. This is called a seasonal index. Again, the interpretation is that on Saturday you can expect that on Saturday a sale will be 34% above the sale, above the average sale of the season, and then this is 0.87, which means sales on Sunday will be 13% less than the average sale, and then this is 0.79, which means sales on Friday would be 21% less than the average sale in that season. And this method is called as centered moving average method. So again, the first step was calculating moving average, and the second thing is that we rearrange it in a way that these values they are centered, so that for example this one 188.3 and all other values, they correspond to the central value. So we have like 3 period, and Saturday is the middle value, so we place it in front of that, and this is called as centered moving average, and I can write here centered moving average. And over here we just take ratio of time series divided by centered moving average. In the next step we take average of similar seasons, and then a step normalization, and that's our overall seasonal index. Now the next step could be that if let's say for example we have this data that's, let's say, Friday, Saturday, Sunday, and this is time series, that's just some random numbers, and you want to incorporate seasonality. You know that this is just data and it does not include seasonal element. So what we do is that we will multiply each value by the seasonal index. So Friday 159 multiplied by F4, and then Saturday will be this value multiplied by this one and converted into absolute value, and Sunday 154 multiplied by seasonal index on Sunday F4, and this one, this new column that shows sales whereby seasonality has been incorporated. So initially without seasonal index it was 159 on Friday, but after incorporating seasonal index it's reduced to 125.49, because we know that on Friday sales is less. Similarly, if we talk about Sunday sale was 154, but after incorporating seasonal index, it has been reduced to 133.66 because we again know that on Sunday sales is less. And when we talk about Saturday, Saturday sales was 151, and including incorporating seasonal index, it has increased to 202.77 because we know on Saturday sales is 34% less than the average value. So that's called as incorporating seasonality. An exactly opposite scenario could be deseasonalization, which means there is we got something and seasonality has already been included in it, and we want to strip away that seasonal element. We want just plain forecast that is without seasonality. In that case, we divide these values by the seasonal index, and that will give us deseasonalized sales. So for example, 125 are divided by seasonal index for Friday, this one, for Saturday divided by seasonal index of Saturday, on Sunday seasonal index for Sunday, and now we get deseasonalized sale, which means the one from which seasonality element has been taken away. So again, in deseasonalization, we divide these values by the seasonal index, and as you can see here that on Friday it was 125.5, which means it had already included a seasonality, that's of course which is less 0.789. However, once we take it away, then that sale forecasted increases. So this is called as deseasonalization. Now, one last thing in the centered moving average method is that suppose if we have we just did here centered moving average method, and we were assuming that there are like odd number values, and we rearrange or sort them. When we center them, we place them in front of the middle value. That makes more sense when you have odd values, but in those cases when you have even number values, then we may need one extra step. Now for instance, let's say this one, we have like here 4 seasons: Thursday, Friday, Saturday, Sunday, and then the same season is being repeated. So first of all, let's calculate moving average, and because this is 4 period moving average, so we have to use 4 period moving average, and which mean is equal to average of these 4 seasons, 4 periods, okay. Now next thing is that again we want to assign this 191 where it belongs, but of course over here there is no central value, so we cannot assign this one to any central value because Thursday, Friday, Saturday, Sunday, these are even number values. But we can assume that this 191.25, it belongs somewhere between Friday and Saturday. So what we do is that I will place these values here in front of second one, and then in the next step I will take another average. That will be average of these two values. That's average of these two values, and then the same pattern will be repeated next. Now This is something that's equivalent to centered moving average. And next step is same, which means we will divide time period by centered moving average, and this is seasonal index, whereby series will be divided by centered moving average, and then we will continue with this one. And then the next step will be that we take average of similar period. So for example, this is average of Saturday, Saturday, this one is also Saturday, Saturday, and Saturday. And then I can drag it, and that gives a seasonal index for this data that has 4 periods. And then we can go one step further, which means we can check what is the sum, and if sum is 4, then it's okay. If it's not 4, then we will do one extra step, whereby we will divide each value by their sum and multiply by 4, and that's called normalization. And the rest of the process is essentially the same as we have discussed earlier. Next forecasting method is called as regression. And in this regression, you see in this data we have independent variable, that's y, that's number of weekly riders, and then there are independent variable for instance price per week, population of city, monthly income of riders, and then parking rates per month. And in this case, for forecasting, we use regression analysis, and for that you click on data and then data analysis. We go on regression. In regression, our input y range is this one, and input x range, that's independent variable, is this one, and we want our results to appear here, and then click OK. And that gives results of regression. Now the next thing is that how to interpret that, or how to write an equation for this one. That equation will be used for next forecasting. So let's say we write question like forecast for next period is equal to intercept, and intercept over here is this value plus slope and of x1, that's x variable 1, x1 plus slope x2 variable plus slope x3 and finally slope of last variable. Now that's the equation that we will use for any forecasting of future. Intercept is this value, and slope for variable 1 is this one, slope for variable 2, 3 and 4. Now, for example, let's say if we make a forecast for next period, or let's say with a different set of variables. So what we will do is that we will use intercept. Intercept will remain same. Then we will use another variable. So for example, price per week. If we say price per week is changing, let's say if it becomes like 100 or something, we will place it there, and slope is already there. And then population of city, if we want to experiment with different population, we will put it there, and slope is already there. And for slope 3, variable 3, that's monthly income. Let's say if that monthly income increases to something 18,000, and we will write here, we will substitute this one with 18,000, and slope is negative 1.301. And the last one is variable 4, which means parking rates per month. If we want to use a different variable, let's say 250, you will substitute x4 with 250, and its slope is 152.4564, and that will give you a forecast for with when using different types of variable. And remember, intercept is the value of y when x is 0. So that's the whole equation. And again, the purpose of forecasting is to do the purpose of regression analysis is to do forecasting. Some other things that are important over here is that one thing, these values, and another thing that we will discuss later on in hypothesis testing is these p-values. So this p-value is very low, which means variable 4, it has significant effect. And this one is also very, very low, because this is 10 raised power minus 7, which means 0.06 times 305, which means this one also has a very strong effect. And variable 2 and 3, their values are greater than 5%, which means if we want to further refine this analysis, maybe we could eliminate this variable, or we can say that their effect does not appear to be significant. So that's called as regression analysis. The next thing is that we want to use regression analysis when we know there are different quarters, and we want to develop an equation, and we want to do forecasting to forecast sales in different quarters. So the first thing is that let's say is that how this data is arranged. If you have 4 quarters, so for example in this case we have 4 quarters, 1 2 3 4, 1 2 3 4. In that case, the rule is k minus 1, that's number of quarters minus 1, which means 3. So we'll use 3 dummy variables, q1, q2, and q3. If we have like 5 quarters, then we will use 4 dummy variables, q1, q2, q3, and q4. And this is sales. And it's very important that data is organized in the right way. So for example, when we are talking about first quarter, then Q1 is 0, and Q2 and Q3, Q1 is 1, and Q2 and Q3 will be 0. When we are talking about second quarter, then Q1 becomes 0, and Q2 becomes 1, and Q3 is 0. When we talk about third quarter, then Q3 becomes 1, and other 2 quarters become 0. So, and when we talk about quarter 4, then all these Q1, Q2, and Q3, they become 0. So in other words, the rule is that only the season that is currently relevant, that will become 1, and all others, they will become 0. And the same thing is repeated for year 2, year 3, and year 4, and year 5, and onwards. And for this purpose, what we do is that over here we again use regression analysis. And in regression analysis, our input y range is sales, and then our x variables are these quarters, and we want our output to appear in G1. So this is regression analysis. Now we will use the findings of this regression analysis to develop forecasting for different quarters. So let's say we say here is quarter number 1. So the formula for this one will be that is equal to intercept. This is intercept plus because we are doing for Q1, so we will be only using the slope of this one, and that will be multiplied by 1, and all others they will become 0. So with 0, which means we are not even going to use them. And in the same way here is equal to intercept plus, because this is for second quarter, so only second quarter, this one multiplied by 1 plus other becomes 0, which means we don't have to mention them. And then again this one is equal to intercept plus this one, it will be multiplied by 1, and other this variable and this variable they become 0, so we don't have to mention them. And the last one is equal to intercept, and then all other they become 0. So this x variable, this x variable, and this x variable they become 0. So in other words, sales for or forecast for quarter 4 will come only from intercept. As you see here, its intercept is 95 and 95 is here. So that's the way by which we see when we are only dealing with quarters. And now for example, just one more thing, as you can see here that in this chart there is no trend, which means we do not see any trend upward or negative. So which means the only thing that's relevant here is quarters. So for this one we use this method. And if I could repeat it very quickly, the first thing is that we need to decide about number of dummy variables. If we have 4 quarters, then we'll be using 3 dummy variables. If we have 5 quarters, then we'll be using 4. So k minus 1 rule, and only that dummy variable that's representing quarter that's relevant is 1, and all other becomes 0. So for example over here, that's about this is 125 is the data for quarter 1, so quarter 1 is 1 and all other are 0. This is data about second quarter, so Q2 becomes 1 and other 2 become 0, like this way. The next thing is that we might have a situation where there is seasonality and then there is trend. So for example, let's say just look at this data, and in this data if we make a plot, you can clearly see here is some trend. So for instance, let's say the first value is something something close to 4.8, less than 5, and the other one is very close to 8.5 or 8.4 something. So there's clearly a trend. So which means this is a situation in which we have to deal with two things. One is quarters and seasonality, and other is there is also a trend. So what we do is that again we summarize this data, but the only thing is that we just add here a period that will be representing trend. These are quarters that represent seasonality, and again the same logic is that we have 4 quarters, and therefore using k minus 1 rule we'll be having 3 dummy variables, so will be 3. And this is 4.1, that is the sales for first quarter, so we here it's Q1, and other 2 quarters they become 0. This is sales for second quarter, Q2 becomes 1 and other becomes 0, and this is period, that's just 1 2 3 and like onward. And for this one again we use the same approach. We use regression analysis, data analysis, and then this is our independent variable, and then input, and then input it will we will consider these both which mean quarter and period. In the previous one, that was only seasonality. We only had input that consisted of quarters, but over here it's a quarters plus period. And then in output range, I want my results to appear here, and these are results of regression analysis. Now we will be using that to do forecasting, and for this purpose what we do is that is equal to intercept plus slope. Let's say for q1, and this is q1, and that will be multiplied by 1, and q2 and q3 they will become 0, so which means we don't have to mention q2 and q3 because they will be multiplied by 0 and they will become 0, plus this one that's representing period multiplied by, we are doing forecast for which period? 17. 16 is already here, 17, so we multiply by 17, and that gives us forecast for period number 17 is 7.18, which means it includes both seasonality and trend. And similarly, when we do for 18, it's equal to intercept plus slope. No, this is q2. F18 will be representing q2, so we choose this one, and that will be multiplied by 1, and q1 and q3 they will be multiplied by 0, so we are not going to mention them, plus this last slope that represents period, and that will be multiplied by 18, and that is 6.65, and finally is equal to, for F19 is equal to intercept plus now this time this variable will be multiplied by 1 and all others will become 0, plus this variable slope multiplied by period 19, and that's 8.53, and the last one is that intercept plus, no, these q1, q2 and q3 they all become 0, irrelevant, and the only relevant thing is period, that's about trend, so plus this one and multiplied by 20, that's 20th period, and that's 8.98. So this is the method how to do regression analysis and find seasonality when your data has a seasonality different quarters and it also has trend. Now let's do a little bit one more example. Now in this example, that's problem number 24. We have this data, and again this data has been orchestrated in this format. This is our original data, that's which means 71 data for year 1, 71, 49, and this data, and then under this data the data of year 2 is appended, and under that data of year 3 is appended. And again the first thing is that we want to see that is there any trend in this one or not. There is no trend, which means we are only dealing with quarters, with forecasting of different seasons. So what we do is that we do regression analysis, and in this regression analysis our input is sales, this column, and our independent variable are these, and output range, I want my results here. Okay, now for this one what we will do is that its forecast for quarter 1 is equal to intercept, this is intercept plus q1, and that will be multiplied by 1 and all other they will be 0, and similarly over here is equal to intercept plus this next one that will be multiplied by 1 and other will be multiplied by 0, and the next will be again intercept plus this q3 multiplied by 1 plus other multiplied by 0, so we don't mention them. And the last one is intercept plus q1, q2 and q3 multiplied by 0, which means there's no need to even write them. And so we get this forecast. Okay, now we move to the last question. And in this question again we do the same thing. First of all, we see if there is a trend in data. Yeah, there is a trend. So we see here this is a starting point and then there's an upward trend. So it means in this data we will be dealing with two things. One is quarters and other period. So let's proceed with regression analysis. We go to data and then data analysis and then the regression, and our dependent variable is this one, and independent variable in this one there are two type of thing. One is quarters and other is period. Quarters that represents seasonality, and this period it represents trend. And we want our results to appear at this place and click OK. These are regression results. Okay, let's go for forecast for period 13. This is equal to intercept plus slope of q1 is relevant, so that will be multiplied by 1, and q2, q3 they will be multiplied by 0, which means they are irrelevant, plus this seasonal this period element multiplied by 13 because we are doing for period 13. And next one is again intercept plus, now this time this q2 it will be multiplied by 1, and q1 and q3 they will be multiplied by 0, plus this one multiplied by 14, and then is equal to intercept plus q3 multiplied by 1 and q1 and q2 multiplied by 0 plus period or trend variable multiplied by 15, and the last one is that is equal to intercept plus q1, q2 and q3. These three they become 0. However, the other one that represents trend, and that will be multiplied by 16, and that's 9.91. So in this one, in this problem, what we did is that we considered two things, quarters and also trend. In this forecast, that's forecast for period 13, 14, 15 and 16, it incorporates both seasonality and a trend. In this video we discussed moving average, weighted moving average, exponential smoothing, and how to determine accuracy of these forecasting methods. And then we discussed seasonality element by using simple average method and centered moving average method, and how to incorporate seasonal index, which means multiplying your forecast with seasonal index. And if you have to deseasonalize, we exactly do the exactly opposite of this one, which means we divide our values by seasonal index to deseasonalize the effect. And then finally we did regression, whereby we discussed regression, simple regression, and then a regression whereby seasonality with trend and without trend they are also incorporated.